So we're looking at perimeter here. Now, perimeter is basically the boundary around an object or a shape. So we've got here a square, and we can see that all sides are the same length, and we'll talk about that in a minute. But what the boundary is, it's the lines surrounding that square. So we can see that there's 4 sides, so we add all those together to get the perimeter. Now in Australia, we'll generally be using millimeters, centimeters, meters, and kilometers is what we use in the metric system. Now, what you also notice is that with this one here, you'll see that there's dashes on each of the lines. Now, what that indicates is that each of the lines are exactly the same. So if there's one dash on all of the lines, it means that each length is exactly the same. So we're going to start solving this one first. We can see that this one's a square, all lengths are the same. So this side is equal to this side, which is equal to the bottom one, which is equal to the left one. Now the way we start this off is you say perimeter, so you start with a P. So you go perimeter is equal to, now we want to add up all of the sides we've got. So firstly what we want to do is we go, okay, we've got here, so we start with this side, the top side, so we've got 5 centimeters. Now a helpful little tip is to cross off the sides as you go as well, because once you get to a problem which has quite a bit bigger perimeter, then it can get a little bit more complicated of remembering what you've crossed out. So here I've done the top line. Now I'm going to do this side, the right line now. Now we can see that the right line is equal to also the top line. So that is also 5 centimeters. So plus 5. And we're going to do the bottom line as well. Plus 5. And then plus the last line, which again is the same length. So plus 5. Now what you can see is that all the lengths are the same. You can see I've gone around the boundary of this square. So all we need to do now is add all of these numbers together to get the perimeter of this square. So we've got 5 plus 5 plus 5 plus 5. Add all of those together and you're going to get 20 centimeters. So the perimeter is equal to 20 centimeters. Now we're going to look at the one just below. So this one here, we've got 7 centimeters. We've got a blank side again, but then we've got 10 centimeters on the bottom. So what this means here is that, well, we've got a 7 centimeters on this side, but we've also got those lines there, meaning that they're actually the same distance. So we've got 7 centimeters plus 7 centimeters plus the 10 centimeters. So we just write that out. So you go perimeter is equal to, now just get a different color. So 7 for the first line. Now we're doing the next line, so plus another 7 plus the bottom now, which is plus 10. Now add all of those together again, and you'll just get the perimeter around that triangle. So we've got 7 plus 10, which is equal to 24 centimeters. Cool, that was a nice easy few. Now we're looking at the next shapes now. Next one we've got here is a rhombus. Now a rhombus, we can think of it as essentially a pushed over square. You can imagine you've got your square here. You can imagine you've got your square here. So you can imagine it just looks like a normal square. And all the sides will be the same, but what's actually happened here is that we've pushed it over. We've lent on one side of it and we've pushed it over, so it becomes a rhombus. So it's now got the slanted edges. Now what we want to do again, this doesn't change anything in the way we solve it. We want to find out the perimeter. So the perimeter is equal to all the surrounding boundaries. So we've got 4, so we've got a 4 plus another 4 plus another 4 plus the last 4. So just add all of those perimeters together, and then we've got 16. Now we've noticed this one here is a little bit different. We've got 16 meters. It's all measured in meters. The next part here is we've got a parallelogram. Now a parallelogram here, we can see that there's actually dashes here. So we've got one dash and another dash down here, which they're both singular, meaning that they're the same length. What we'll also notice is that now there's actually 2 dashes on the sides of it. So we've actually got 6 kilometers here with 2 dashes. and we've got another 2 dashes here. Now what that means is that that's actually different from the 10 kilometer line. Sorry, that should be kilometers. Is different to the 10 kilometer line. They're not the same length. However, the 2 sides are actually the same length. So this here becomes 6 kilometers also. So the perimeter of this one is equal to 10. So we're going to add the top, and then we're going to add the bottom together. So 10 plus 10, and then we'll just add the 2 sides. So plus 6, which is equal to 2032 kilometers. Now the last ones we've also got up here is a kite. Now with the kite we can see that the top 2 lengths are going to be the same for it to form a kite, and the bottom 2 are going to be the same to form this kite as well. So just taking it a little bit step further, we've got 5 meters at the top, meaning that this one is also 5 meters, and we've got this one here with the 2 dashes, meaning that's also 8 meters as well. So you've got 5 plus 5 plus 8 plus 8 is equal to 26 meters. Okay, now this last one here is a bit of an odd shape, so we've got to work with what we've got. Now this one's going to be a little bit more complicated, so this is where drawing over the lines is going to help us out. So we're going to make sure that we get every single border around this shape here to get the perimeter. So we're going to start off with right in this point here. So we're going to go across. Now we know that if that's 3 centimeters, it's saying that there's a dash and there's a dash there. Even though they don't look the same, they're actually the same distance apart, so they're both 3 centimeters. So you have to just forgive the drawing in this situation. So we've got 3 centimeters to begin with. Then we've also got another 3 centimeters here, so that's plus 3. Now we're going to add all these 3's. We're going to go to the 6 now, so we've got a 6 here. Now we've got 3 lines going across down here. Now we can see that that is the same length as this one, which is the same length as this, because they've all got the dashes in there. And the dashes meant that they are 3 centimeters. So there was 3 of them in total. 1, 2, 3. And then we've got one more at the top, which is again 3 centimeters, because you can see the dash with it. Now this part here, a little bit more complicated, they've left it blank. Now this one here, because it's left blank, we can still actually solve it. Reason being is that we can see that, well, this height here is actually equal to these 2 heights together, the 3 centimeters and the 4 centimeters. So we can see that if we drag this 3 centimeters all the way across to the end here, we're going to have 3 centimeters here. And if we dragged this 4 all the way across, so we're just going to cut it in between there, it's going to be 4 centimeters down there. So when we actually add all of those together, we're going to get a total of 7 centimeters. So that length from here to here is actually 7 centimeters long. So we can actually write that down into the list there, plus 7. Now we're only 2 more to do, which are quite simple. So we got 15 down the bottom, so plus 15, and then we got the last side, which is a plus 4. So again, we add all of this together, which is equal to, now we got here, we got 6, plus 6 is 12, plus another 6 is 18, plus another 6 is 24, plus a 7 is 31, plus a 15 is 46, plus the 4 is 50. So we have a total here of 50 centimeters. Thanks.